Hello everyone. This is our first lesson in CS224 course and we will learn about assembly language using Mars program. In order to use Mars program, first you need to download it by just writing Mars assembly, go to Missouri State University Mars Lab Simulator, and then you go to download. As you can see the button over here, you press on it, and then you press this and it will download it immediately. It might ask for Java updates, so make sure to update your Java to the last update they have already. While downloading this, it's very important to download this paper, which is called Mips Green Sheet, and you can find it by writing Mips data reference in the Google search bar. Mips Green Sheet, it's a sheet that we're going to use in this course, not in this not in this video at least, but like we're going to use it in this course, and it contains everything you need to know about Mars, and also it contains some stuff you need to know about assembly language, and therefore it's very, very important. Once we are done with downloading Mars, let's just run it. Mars 4 underscore 5. Yep, here we go. Once you are done with Mars, just run it so we can start working. But before we start all of this, I want to say that this course won't be totally about coding. So I'm just going to teach you the very basic of coding, maybe for the first 3 or 4 videos. And next, we will go to course materials and how to solve questions and so on. So if you wanted to learn assembly language in more details and depth, I would suggest you watch MIPS Assembly Programming Simplified in 38 videos in a playlist from Emil Peralta. It is the way I learned how to code in assembly. I just watch his videos and I just like doing what he does and understanding every part of the code. Okay, today our program will be about how to print hello world in Mars, and therefore this is gonna be the video about. We're just gonna print hello world in Mips. Basically, go here and press create a new file for editing, right? Control S to save this file. I'm gonna save it in Mars tutorial here, and I'm gonna call it program. Prog stands for program, prog.1 assembly, and yes, I'm gonna save it here. So there are two things you need to do as soon as you start your Mars program, which are dot data, okay, and dot text. These are the very basics that you need to do as soon as you start your program before you even code. These are like cultural things in this coding, and then you need to have it. Okay, let's explain one part by one by one. First, we have the data segmentation, and this is to store the strings and array contents, addresses. Cool. We put it in data part, and then you have dot text, and here where we code. Basically, the code is here and the data is here. First of all, we said we want to print hello world in this program, and in order to do this, we're gonna do the following. First of all, you need to have a variable that contains hello world. In order to have a variable, you need first of all to initialize the variable. And let's say that I'm gonna call the variable hello. Basically, I'm gonna just write hello, and then two upper dots, and these two upper dots are like equal sign in any language. Like you want to say string hello equal to hello print world in Java, for example, but in assembly language it is just upper two dots. And then you're gonna write your sentence, or the sentence you want to store in data, or like in hello, you want to write it in ASCII code, in ASCII, so it's easy for the program to understand it and change it to an address. Why an address? I'm gonna explain in the next following minutes. Cool. After you write ASCII, you're gonna write hello world in quotation mark. Like in any normal coding languages, we store the strings inside quotation marks. So now I have a variable that's called hello, stored in hello world in .ascii part. Now I want to take this hello world and to store it in one of the registers. What are registers? It's the stuff that we have at the most right. As you can see, there are registers numbered from 0 to 31, and these three are not important right now. I'm gonna go over them in the future. Basically, you have like 32 registers: 0, ATV0, A1, A0, and all of them are explained in the datasheet, as you can see here. If you go here in the first page, in register name, number, use, call convention, you're gonna find this table, and this table explains everything. So we have a register slash $0, and the usage that to use it is just the constant value 0. Not very useful. Then what about AT? It's an assembler temporary. Well, someone who's watching this video, don't understand these stuff. You don't need to understand them right now. All you need to do is to become familiar with them. So we have values for function, result, and expression evaluation. We have v0 and v1. We have this as a return statement. Let me explain it in a better way. Basically, V registers are for evaluation and results. Like you put the results in V registers. You have A registers, and these are for arguments where you want to send a register. You want to send the value from a label to another label. And I'm going to explain all of this in the future. You don't need to worry about it right now. And then we have temporaries where you put the data inside the temporaries, save temporaries, and another also temporaries. For k we don't care about k in this course. We don't care about the global pointer in this course. We care about stack pointer. I'm not going to explain this. You can watch it in ML videos that I already showed you, like how to access them. Frame pointers, we don't use it. Return address, we will use it as well. Okay, so basically after I explain them, I know that you don't understand them right now, but by time you will understand. Let's go back here. First of all, as I said earlier, we have hello as a message, and they want as a string, and they want to load it to one of the registers, and I'm just gonna store it in T0 register. So since hello world is just an address, I'm just gonna write load an address in the program by just writing LA, and this means load address. Cool. When you write the name of the method that you want and you press space, we're gonna find how to write the code in many ways. So for example, I want to load address, and hello is a label, right? So I just want to write it in this way, LAT1 label. And this means set the label's address to T1. So basically, I'm just gonna write, yeah, and here, it's not T1. Here, T1 is just an example. So since we have 8 registers from T0 to T7, I'm just going to use T0 because it's available right now. There is nothing inside T0. And then I'm just going to write hello, which is the address. And then this means that T0 is equal to hello world message or address. Okay, now you need to print this um, string, and it's very easy to do so, but it is complicated. So in Java, in order to print stuff, we just write println, right? And then we just can write here hello, and basically it prints. In assembly, it's done in a different way. First, you need to go to help, and after this, you need to go and read how syscall works. Syscall stands for system services, and then system calls. So basically, it's just respond to system calls. I want to print a string, so I will go to this table of available services, and I will look for a service that's called print a string. How to do so? Code in v0 is 4, so basically you need to put 4 in v0, and the arguments should be coming from a0, address of null terminated string to print. So basically you need to put the string in a0, and you need to put v0, you need to put 4 in v0 in order to print the statement. So basically how to do this? I can write LA A0 hello. And this also means the same as this, but instead of T0, it's just gonna be an A0. So basically now hello world address is in A0. Next, I'm gonna write load immediate. What does load immediate means? It means that put the thing you want, anything you want, a number, let's say it's a number, put the number you want in a certain address, in a certain register that you give us. And in the help part, it says that it should be in V0, right? Code in V0 is 4. So basically I'm just gonna write V0. How do I know it's V0? It's written here. Set the 16-bit immediate to T1. So basically the answer is gonna be T1 equal to 4. And this means V0 is equal to 4. So far so good, right? After you're done, you just write syscall. What does this call means? Syscall is gonna look for the value of V0 first. V0 first, yes. If V0 is 4, it's, oh sorry, my bad. If v0 is 4, it's gonna look for the code in v0, right? Syscall is gonna look for v0. What does v0 contain? v0 contains 4. Then it's after it knows that it's contained 4, it's gonna look at the arguments. What is the argument? It says that the argument should be a0. So basically, in order to print the thing we want, we need to put the thing we want in a0 in order to print it in a string. So a0 should be pointing to the address of hello world, and we already have done this. a0 is hello world right now by putting the label to a0, and then we call for in order to print the string, because v0 when it's 4 it just prints a string, and therefore the program works. Let's run the program by pressing this button, and as you can see here, hello world prints. As you can see here, the program prints hello world. Let's take it step by step in order to see what happens. First of all, we have edit part where the code is here, and then we have execute part where the code is here. We have text segment and we have data segment. Text segment is everything you have in this code part, which is under the label .text. And then we have the data segment, which is everything from .data till .text. So basically, we should have the address of hello world inside the .data, right? .data segment. And as you can see here, there are numbers and values, and these are in hexadecimals. If you want to see them in strings or like display the data segment values in ASCII, you're going to print this button, and you can see hello world, but it's written in a weird way, so we won't care about this. We just make sure that hello world exists in data segment. Let's take it step by step. Let's do the code step by step. So first of all, we're gonna load hello to T0, and as you can see, T0 now in the register file contains the address of hello world, which is 1001000, and as you can see, hello world is in this address. Next, we do the same to A0, and ta-da, it's done. First, we assign v0 to 4 by writing load immediate v0 4, and this means put 4 to v0, and as soon as we press this button, we're gonna find this v0 equal to 4 in hexadecimal, and yep, it's in hexadecimal. Now remember, a0 and t0 are not in hexadecimal as in addresses. They are not data, they are addresses. 4 here is a number, like hexa number, so 4 is in v0. Next, we press on syscall, and I already explained what does this syscall does. Syscall check for v0, and after it sees the number that contains v0, it looks at the register, and it sees what we want to do with that register, with that thing inside the register we have. After we press this, run one step at a time, it's going to print hello world, and therefore we are done. And this is how to print hello world in assembly language. That's everything for today. Hope you have learned something new. Have a good day.